Hey, how's it going? Today I'm going to be talking about continuous liquid interface production, CLIP, and what that is. Material handling. Handling liquid resin materials can be messy and require careful storage and disposal, and some resins may have specific safety considerations. Technical expertise. Operating and manufacturing clip 3D printers may require specialized knowledge and training, especially for optimizing printing parameters and resin selection. Thanks for watching, and I will see you next one. Continuous liquid interface production is a 3D printing technology developed by Carbon 3D, a company founded in 2013 by Joseph De Simone. There are a couple other members within the team, and they are using a resin-based 3D printing process that uh, differs significantly from traditional layer-by-layer 3D printing method like fused deposition molding, FDM printing, or stereolithography, SLA printers. The most common ones, the most popular ones, the one that you would have layer by layer printing, as well as you would use SLA, would be container filled in with resin that would use UV lights to print any of the parts. Let's take a look at some of the key features and principles for CLIP technology and what they are. Continuous printing, unlike layer-based 3D printing, clip creates objects continuously without the need to build them layer by layer. This continuous process results in faster printing times. Photochemical process clip use a combination of UV lights and oxygen to cure liquid resin into solid objects. This process is known for photopolymerization. A special oxygen permeable window is placed at the bottom of the liquid resin container to create an oxygen dead zone where curing does not occur, allowing the object to be pulled out continuously. High-speed printing, because clip does not rely on the layer-by-layer approach, it can produce objects significantly faster than many other printing methods. The speed of clip printing depends on the factors like the size of and complexity of the object that you're looking to produce. Wide range of materials. Clip is compatible with variety of liquid resins, including those designed for different mechanical process, colors, and transparency levels. This versatile makes it suitable for a wide range of applications, from prototyping to functional and use parts. From my personal experience from resins and using UV lights and what you can potentially gain in terms of how much pressure material is going to be able to handle. Not necessarily that much. Well, perhaps with the new technologies coming in, there might be some changes. But other than that, what you would be able to produce from resin, just overall common sense, I guess. What you would be able to produce, what parts or end product you would receive. Not necessarily if that material would be able to hold a lot of pressure, and most of the time, uh, work that you would receive might be very detailed work, and it might look great on the shelf. But if you would be looking for use cases, you not necessarily would be able to have this end piece very durable to, for example, to have it as like perhaps shoes or something that would be constantly under pressure. Perhaps new different materials coming into play, new inventions coming in, new technologies being invented every day. Perhaps there's gonna be some changes, and overall, I hope for that, and hopefully in the future there perhaps will be no new processes and ways to develop new technologies and things. But currently, I don't believe that perhaps this is the best way of doing it, especially depending on what kind of problem you're looking to solve. Smooth surface finish. A clip technology typically produces objects with smoother surface finish compared to traditional layer by layer 3D printing methods. This is because there's no viable layer lines, and the continuous process allows for more precise control over curing of the resin. Support structure. Just like other 3D printing methods, clip may require support structure for certain complex geometries. These support structures are typically made from the same material as the object and are generated automatically by the printer's software. Currently, perhaps best approach would be yourself if you are interested in overall different ways of manufacturing things. Do a little bit of research, take a look at some of examples out there, and what you kind of examples you might be able to do and use cases for 3D printing. And if you were to design any interesting example of you, and if you would be able to find a use case for it, there's a definite potential for that. Just again, be careful with the intellectual property, especially from the point that you would begin making money from your invention. It's something that, if you have a really good idea, just be careful with intellectual property. Caveat: using other people's licensed intellectual property, as well as perhaps creating your own intellectual property. Do your own research, as well as what are limitations would currently within the industry, and what are examples within the industry, and how far you can take this as a 3D printing as a hobby. Can you progress from a hobby into a business, and would that be a valuable business? And perhaps doing a little bit more research, I would highly recommend for taking a look at that, especially for future. Perhaps there's some potential there for those of you who perhaps looking to generate some extra money coming in. It might be a lengthy process to build a clientele and perhaps to get the business rolling. But if you have a printer already, or if you are planning to printing something for yourself, perhaps it's very interesting overall thing to do and to have. I guess that's what I'm going for. For those of you who are interested in launching your own business, I would highly recommend to purchase my book. I have recently published the book Rise Impact. In the book, I'm sharing a lot of information of everyone for everyone who haven't started business, or perhaps considering starting a next business that would be livestock business, and what would you need to know when starting your own livestock enterprise. In the book, I'm sharing a lot of information of the first milestone, which I believe is important, especially when it comes to business, to structure your goals around finance and how you can adjust those. There's a lot of motivation for a lot of people to start a business, especially to make some money. Uh, from there, perhaps you can enjoy enjoy doing that. There's other reasons and reasoning behind starting a business and having more independence and all the other good things. But other than that, you can find this book in the description below, as well as top retailers has it. Pros of clip. Speed. Clip is significantly faster than many traditional layer by layer 3D printing methods because it operates continuously. This makes it ideal for rapid prototyping and small batch production. Smooth surface finish. Clip technology typically produce objects with smooth surface finish, as there are no visible layers lines. It seems like this particular printing method was invented to solve a very particular problem. This is the impression that I'm getting. This is advantage for applications where aesthetics and surfaces quality are important. Material versatility. A clip is compatible with a wide range of liquid resins, including those with different mechanical properties, color, and transparency levels. This versatility makes it suitable for various industries and applications. Complex geometries. Clip can produce complex and intricate geometries with ease, thanks to its ability to create objects without the limitations of layer by layer printing. Again, overall the way how everything's been structured to solve a very particular problem. So if entry level printer would be layer by layer, commonly known, perhaps some group of people who came up with this particular principle on how to manufacture. They were in particular trying to solve very particular problems within the industry. Cons, some of the major cons would cost. Clip 3D printers and the associated resin can be more expensive than some traditional 3D printing technologies, both in terms of initial investment and ongoing material cost. Limited build size. The build volume of clip 3D printers may be smaller compared to some other 3D printing methods, limited to the size of objects that can be produced in a single print. Post-processing. While clip produce smoother surfaces than many 3D printing methods, post-processing may still be required for some applications to achieve specific surface finish or remove support structures.